us. So this is the third lecture of the course, Information Theory and Coding. In the last two lectures, we have discussed what is an information, and particularly we focused on what is the information, amount of information present in any particular message. And we observed that if the probability of occurrence of any event or any message is less, then that particular message conveys maximum amount of information. And we took some examples of different messages. One example we took in the previous class, sun rises in the east. And since the probability of occurrence is 1, so this statement contains 0 information because it has no sense or no meaning. If you say anyone that sun rises in the east, then definitely people will surprise you. What's new in that? Or is it a statement? Okay, so when we talk about any message particularly, so all message does not have the equal amount of information. It depends upon the probability of occurrence of that message. If you tell tomorrow it will be heavy rainfall, then that particular statement, that particular message carries maximum amount of information. Or if IMD, Indian Meteorological Department, announces something that tomorrow the wind speed will be around 100 kilometers per hour. So this carries some information because it has very least amount of probability or probability of occurrence. And we have established one relationship in between the information that is called the self-information and the probability of occurrence. And what we saw in the previous class that the information content or the self-information is inversely proportional to the probability of occurrence. That means if the probability of occurrence is 1, then the self-information is 0 and vice versa. And further, we represented this relationship by logarithmic. So we represented self-information that equals to log base 2, 1 divided by probability of occurrence. And we discussed why we are taking the logarithmic. And if we take log base 2, the unit will be bits. If we take log base 10, the unit will be decits. And if we take the base as E, then units will be nats. So it is up to the user which unit, by which base the user can represent the logarithmic expression. And followed to that, we discussed what is the average information content in a long bit stream of information. And we established the relationship that we call average information H of S, that is the summation of I is equal to 1 to n or any variable probability of I log base 2, 1 divided by probability of I, and it has unit bits per symbol. So this one is called the average information, or we also call it as entropy. So when we represent this entropy as a function of S, so S represents my source. If my source is S, we generate some sequence of symbols like S1, S2, S3, so on up to Sn. So that is the reason why I represented this function h as a function of s. So s is the source. And with this, we also have discussed one more term that is called the information rate, which we represented by a symbol that is capital RS, where S is the subscript. And we discussed the information rate is the average information multiplied by the symbol rate. So we studied that RS is equal to S of S multiplied by RS. And what will be the unit? Since entropy has a unit of bits per symbol, and this one RS, you know, RS is symbols per second, that is the symbol rate. So the unit will be bits per second. So the unit of information rate is bits per second. So these are the things we discussed in the last two classes. And we also had some solved one or two problems in the previous class. And today we are particularly solve as many as problems possible in this particular class. So I will provide you the notes of this class, but I am not touching all the problems which are available with me, but some of the important problems I am going to solve because it is not possible to touch all problems. So let me write the example which we are going to solve this. So this is the question. So read the question carefully. A code is composed of dots and dashes. Assume that a dash is 3 times as long as a dot. That means if a dot is having some length, then the dash is having thrice the length of dot. The dash is 3 times longer than dot. That is the thing. And has 1/3 the probability of dots. Okay. So let us write it simultaneously. So what is the probability given and has 1/3 the probability of dot. So probability of dash is equal to 1/3 the probability of dot. That has been given. Question is to calculate the first bit, information in dots and dashes. Okay. So see the code which is composed of dot and dash, dot and dash, dot, dash, dash. I don't know in which manner it is there, that I don't know. But it is composed of dots and dashes. That's all what I know. So since the code is composed of only dot and dash, there is no other symbol present, only two different symbols. One is dot, another is dash. Okay. So that implies we can write the probability of dot plus probability of dash. Sum of these two probabilities is 1. So this I can write probability of dot, then plus I know that probability of dash I have written here 1/3 of p dot. So this value I can write here 1/3 of p dot. This equals 1. Or if you take p dot as common, so it will be 1 plus 1/3. It will be 4/3. So 4 divided by 3 into p dot is equal to 1. So that implies p dot is equal to 3 divided by 4. So this is one probability which we obtain. So once the p dot is having probability 3/4, we can find the p dash. So what is p dash? P dash is equal to 1/3 of p dot. So that is 1/3 of 3/4. So that equals 1/4 because this 3 will cancel. So we have p dash is equal to 1/4. So probability of dash is 1/4. Now you see the probability of p dot and probability of p dash, if you add, then you are getting this one. What is the meaning of this? The probability of dot is 3/4 and probability of dash is 1/4. So that means if the sequence, if the code, or particularly this question, it is given the code. Okay, it is given the code. So if a code is having the total length 4, okay, so out of the 4 symbols, there are 3 symbols which are dot, and there are only 1 symbol which is dash. Understood? So if you take a code word, this code word consists of 4 different symbols. Out of the 4, 3 are dots, 1 is dash. That is what we understood. Okay, so length of code. Length of your code is 4. Then how many dots are there? Length of dot is equal to 3. Length of dash is equal to 1. So length of dot, that does not mean I'm talking about the length. You can consider this as the number of dot, you can say number of, it will be better, number of dot is 3. So here length of code means how many number of symbols your code contains. Hope you understood this. Okay. So first question, we have to calculate the information. We have to calculate the information, right? So what is the information in dot? So this is the first bit. So information, or that is the self information of dot. This is nothing but your log base 2, 1 divided by p dot. So that is log base 2. What is p dot? 3 by 4. It will be 4 by 3. And what will be the answer? It will be 0.415. So this equals 0.415 and unit will be bits. So always you write the unit. Then what is the information in dash? That we can write like this: log base 2, 1 divided by probability of dash. So that equals log base 2. This one will be 4. So that equals to 2. So this many bits. So this is the answer to the first bit of the question. Second bit, to find out the entropy of dot on dash. You have to calculate the entropy. Number 2. So what is entropy? Entropy is H or H of S. We write like this. This equals summation of I is equal to 1 to 2. I am taking 2 because your code consists of 2 different symbols. One is dot, another is dash. So this is P of I log base 2, 1 by Pi. So that equals this probability is 3 by 4, 3 by 4 log base 2, 4 by 3 plus 1 by 4 log base 2, 4. I have written directly. I hope you followed my steps. Okay, so this is 3 by 4 log base to 4 by 3. We have calculated here 0.415 into 0.415, then plus 1 by 4. This is 2 into 2. So this answer, how much that I have got? 0.8113. This is 0.8113 and the unit will be bits per symbol, because this is the average information. So average information unit is bits per symbol. Correct. Now come to the third bit. You have to calculate the average rate of information. If a dot lasts for 10 milliseconds. Okay. So what you see, what it has been given asked. You calculate, you don't have to calculate average rate of information. Rather, you have to calculate the average rate of information at this particular condition. The condition is given here. In this condition, you have to calculate what is the average rate of information. So condition is, if a dot lasts for 10 milliseconds and this same time is allowed between symbols. That means there is a gap in between two different symbols. How much gap is there? It is given. This same time is allowed between symbols. Same time means this 10 millisecond. That means dot last for 10 millisecond. That means one duration of one dot is 10 millisecond, and dot and dash, a time gap is given that is equal to 10 millisecond. So if I write it pictorially, so you know in the very beginning it is given that the dash is 3 times as long as dot. Okay, so you see in the picture, or I will do the picture here. This I am drawing a code. So this is my code. This is dash, and or this is dash. This is dot. This is dot. This is dot. So this is one code. Another code can be like this. Okay. So what you observe here, this is one code. This is another code. See, in the first code, there are 3 dots, 1 dash. In the second code, there are 3 dots, 1 dash, but the position of the dash is different because it is not given that how it is arranged. In the question, it is given that in a code there will be 3 dots and 1 dash. Okay. So what is the length of this dot? The length of dot is 10 millisecond. Okay. So its length is 10 millisecond. All dots are having same length, that is 10 millisecond. And since in the very beginning it is given a code is composed of dots and dash, assume that a dash is 3 times as long as dot. So what will be the length of dash then? 3 times as long. So it will be 30 millisecond. It is 30 millisecond. And what is the time gap in between two different symbols? All 4 symbols constitute one code. So these are individually one symbol. So time gap in between two symbol is how much? It is also given. The same time means 10 millisecond is the time is allowed between symbol. So in between symbol, there will be a time gap of 10 millisecond. So then what is the length of your code? Your code consists of 3 dots. Each dot is having length 10 millisecond. So this is the third one we are solving, 10 millisecond. So that equals to 30 millisecond. And your code consists of 1 dash, and dash is having length 30 millisecond. So that is 30 millisecond. And do not forget about the gap in between two different symbols. So how many gaps are there? Between this symbol, 1 gap. This symbol and this symbol, second gap. This symbol and this symbol, third gap. This symbol to the first symbol of next code, fourth gap. So there are 4 gaps. 4 gap into 10 millisecond. That is equal to 40 millisecond. So what is the length of each code word? You sum all, you will have 100 millisecond. Got my point? No question. Okay. So this gap, again, this is another code. This is 1 gap. This is another gap. This is another gap. And here will be another gap. So this is the gap between the last symbol of the present code and the first symbol of the upcoming code. So there are 4 gaps. So the total length is 100 millisecond. Okay. So this is the length of what? This is the length of what? Length of your code. Your code consists of 3 dots, 1 dash, and some gap in between two different symbols. So total length is 100 millisecond. So what we observe? What we observe that 100 millisecond, in 100 millisecond, how many symbols we are transmitting? We are transmitting 4 symbols, 3 dots, 1 dash. So 4 symbols. So in 1 second, how many symbols will transmit? 4 divided by 100 millisecond. So that equals how much? 40 symbols per second. So what we have evaluated here? What we have evaluated here? This one. This is the symbol rate, which is your small rs. So we have calculated the symbol rate. Don't be confused. We have calculated the information rate. We calculated the symbol rate now. Now we have to calculate the information rate. So information rate is denoted by capital RS, that is equal to your average information multiplied with symbol rate. So we have in the second bit we got the value of average information that we call entropy 0.8113. So that equals 0.8113 multiplied by RS, just we got 40. So if what is the result I got? It is 32.452. 32.452. And who can say the unit? The unit will be bits per second. This is the average. This is the information rate which has been asked. Understood now? Okay. Since you don't have any question, let me go to the second example. Yeah, let me wait for some second. If I can copy paste it, it will be good. Yeah, it's coming. Very good. See, this is the question which is given to us. A card is drawn from a deck. You are told it is a spade. How much information did you receive? So first we have to calculate the information. So there is a deck of card, and when you took one card and you got the card is a spade, right? So how many spades are there in a deck of card? There will be 13 spades, right? So then what is the probability that you get a spade? I'm writing here the solution. The probability that you got a spade, 13, there are 13 spades are there out of 52. In the deck, there are 52 cards. So it will be 1 divided by 4. So probability of spade is 1 divided by 4. Then question is, how much information did you receive? We can calculate the information of spade, that equals log base 2 1 divided by probability of spade, that equals to log base 2 4, that equals 2. The unit is bits. This much amount of information present when you took a card and the card is of spade. This is first question, answer to the first question. Second, how much information did you receive if you are told that the card drawn is an S? Okay, so see, many people, you might have played the card games. If you, there are 4 different colors are there in a card. So one is called spade, another is clove, then diamond, and then heart. Okay, and what are the numbers? Numbers are 2, 3, 4, 5, 6, 7, 8, 9, 10, then J, then Q, then K, and last one is A, and A is called as S. Okay, so what are the numbers? 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10 it is J, then Q, then K, then you have A, and this A is called as S. That is the question. How much information did you receive if you are told that a card drawn is an S? So you are drawing one card from the deck. How many cards are there in the deck? There are 52 cards. And how many S's are there? 4. There are 4 S's are there. One is spade S, another is clove S, another is heart S, another is diamond S. 4 S's will be there. So what is the probability that you get a S card? So there are 4 S's and out of 52. So this is 1 divided by 13. So what is the information that you have? Information of S, that is log base 2 13. So this answer is 3.7 bits. Hope it is clear. Now come to the third one. Let me check any question from your side. No. Okay. Third one, if you are told that the card drawn is an S, okay, the card drawn is an S of spade type. Understood? The card drawn is an S but of spade type. How much information did you receive? Try to understand the question. We calculated what is the probability of spade. We calculated what is the probability of S. Now the question is, when you draw one S, it is not a random S. It is a S of type spade. Then how much information did you receive? So in order to get the information, you should find out what is the probability that when you draw a card and the card is an S type, S of type spade. So that probability you have to find. So what you can write? The probability that we get an S of type spade This is a joint probability. This joint probability is probability that you draw a spade card multiplied by the probability that the card is an ace type. Understood? So what is the probability that when you draw a card that is of spade type, this probability we have obtained, probability of spade, that is 1 by 4. So this probability is 1 by 4. Multiplied by what is the probability of S that we have obtained 1 by 13. This is 1 by 13. So it is equal to 1 divided by 52. So this is the probability that when you draw a card out of the 52 deck of cards, and that card is an S of type spade. This is the way of calculating the probability. Now you can use another way of calculating the probability, and that is, see, in a deck of cards, how many cards are there which are S and of type spade? There will be only one card. There will be only one card which is S of type spade. So out of 52. So that answer is, so only one card out of 52. So this is the other way of calculating the probability. Now from this you can calculate the information of S of type spade. So that equals log base 2 1 divided by 1 by 52. That is equal to log base 2 52. And the answer will be 5.7 bit. Understood? Now look at, just analyze what we have done. In bit 1 of the question, we calculated the information of spade. In bit 2, we calculated the information of S. In bit 3, we calculated the information of S of type spade. Among these three informations, if you see, which is having high probability of occurrence, getting a S card is having high probability of occurrence, or getting a spade card is of high probability of occurrence, or getting an S card of type spade is having high probability of occurrence. The answer is getting a spade card is having high probability of occurrence, because in a deck there are 13 number of S's, 13 number of spade cards. There are 4 number of S's, and there is only one card which is S of type spade. So which is having high probability? Getting a spade card is having high probability. So if you see the information here, you will have 2 bit. Which is having low probability? Getting an S card of type spade is having low probability, that is 1 by 52. And if you see how much information here, 5.7, that means the probability is less, but the information is more. If you compare here, the information is 2 bits, but here you see these two comparison, if you make, here information is 2 bits, but here information is 5.7 bits. Okay. Now we have 4th bit. So what is given in the fourth bit is the information obtained in 3, that means this one, is the sum of information obtained in 1 and 2. How much information we obtained in 3? 5.7. 5.7. Is it the sum of information obtained in 1 and 2? What is the information in 1? It is 2 bit. In 2, it is 3.7 bit. So 2 and 3.7. So 2 plus 3.7. Yes, it is 5.7. So answer is yes. The question was, is the information obtained in 3 is the sum of information obtained in 1 and 2? Answer is yes. Because in third question, we have to find a joint probability, and question number, bit number 1 and 2, we have to find the individual probability. And we calculated the individual information, that is called the self information. This is the self information. This is the self information, and here we calculated the total information. Okay, which is the sum of these two. Now we can no, I think we don't have time to take up one more topic. So these are different examples which we have solved. If you have any question, you can ask, or else I'll close the meeting.